Let's look at another example where we're finding derivatives now. So let's find the partial derivative of w with respect to s and the partial derivative of w with respect to t for w equals 2xy, where x is s squared plus t squared and y is going to be s over t. So here, notice my function w is a function of two variables, x and y, but my variables x and y, they also depend on two variables, so s and t here. So this one is a little bit different than the examples we've looked at so far, because before our functions x and y only had one variable, they only had t. So we're going to use substitution here. So I'm going to substitute in my equation for x and my equation for y into my function for w. W will be 2 s squared plus t squared, and y, which is s over t. And then we can go ahead and distribute this. This will be 2s cubed over t plus 2 t squared s over t. So if I simplify that second fraction, I'll get w equals 2s cubed t plus 2ts. So now w is a function of s and t, so I can directly find the partial derivative of w with respect to s. So you'll get 6s squared over t plus 2t, and the partial derivative of w with respect to t will be negative 2s cubed over t squared plus 2s. So there are my partial derivatives. I found them by using direct substitution, but there's another way that I can find them, and it's with another variation of the chain rule. So let's go ahead and see that now. The chain rule, when you have two independent variables. So here I have an s and a t. Those are my two independent variables. So let's again suppose I have a function of two variables where f is a differentiable function of x and y. If x is a function of s and t, and h is also a function, and y is also a function of s and t, such that the first partials, so it'll be the partial of x with respect to s, the partial of x with respect to t, the partial of y with respect to s, and the partial of y with respect to t all exist, then the partial derivative of w with respect to s and the partial derivative of w with respect to t exist, and there's a nice formula for finding them. It's the partial derivative of w with respect to s is the partial derivative of w with respect to x times the partial derivative of x with respect to s plus the partial derivative of w with respect to y times the partial derivative of y with respect to s. And then you have a similar formula for the partial derivative of w with respect to t. Partial derivative of x with respect to t, partial derivative of w with respect to y, times the partial derivative of y with respect to t. So here are my two formulas. Now, one thing I want to make sure to note is that in these formulas, everything is a partial derivative because all of my functions, w, x, and y, they're all functions of two variables. So all of these are partial derivatives. None of these are just the regular derivatives now.